Assalamu alaikum. Hi, good day everyone. So in this video I'm going to share with you the examples of applications of arithmetic and geometric series. So we're going to have 4 examples actually according to this. So let's start with the example 1. Find the number of months it takes to repay a debt of 39,750 by monthly installments. The first installment being 60 ringgit and the amount increasing by 30 ringgit each month after the first payment. What is the final installment? Okay, so according to this, we notice that the first terms, according to this is actually the arithmetic sequence, where we should have our first term, which equivalents to 60, and the second term is coming from the increasing each month. So the amount is increasing 30 ringgit of each month, so therefore we should have the 60 ringgit plus with 30, which should be equivalent to 90, and the third term is coming from the second terms, which is 90 plus with 30, therefore we should have 120 accordingly. Okay, so this is actually the sequence that we have from the example 1 equations. Okay, so according to this, we notice that this is actually the arithmetic sequence, where we have the first term is equals to 60 and r is equals to 30. So coming to that, we have the summations of repay of a debt, which is 39,750. Okay, so in order to find which terms, in order to find the nth terms of having this value, which is 39,750, so what we're going to do is, we're going to let the Sn equals to 39,750, because we know that this 39,750 is coming from the summations of all this value. Okay, then so according to this, we are going to use the formula of Sn. So we should have the 39,750 is equals to n over 2 multiply with 2a plus with n minus 1d. So as having the value of a and d, so we just substitute accordingly the value of a and d here, which is we have 60 and 30. So we should have n over 2 times with 60 plus n minus 130. Here is 39,750. Then in order to cancel 2, we should multiply both sides with 2. Okay, then we should we're supposed to have 79,500, which is equals to n. Here I should have 120 plus 30n and then minus with 30. Okay, then afterwards, after simplify this, I should have the 30n plus with 90, 79,500. Okay, then expand along, we should have 30n squared plus 90n equals to 79,500. Then we should have the a quadratic form, which this should be equivalent to 30n squared plus with 90n minus with 79,500, which is equals to 0. Then in order to simplify this quadratic form, so we should divide them for both sides with the t. Then here we should have the n squared plus with 3n, okay, minus with 2,650, which is equals to 0. So according to this, we should have a factor of 50 times with 53. So in order to get the plus 3, therefore we should have plus 53 and minus 50 accordingly. And here we should have the n value, which is 50 or negative 53. So according to this, since the value of n, we are looking for the positive value, so the negative value here should be rejected. Okay, then finally the value, the summations of 39,750 is actually lying on the fifth terms. Okay, so now we would like to find the fifth term accordingly. because we need to know the final installment that we should pay on the 50 terms. So what we do is we're going to use the formula of the arithmetic sequence accordingly, as now we are looking for T50. Okay, so T50, which means we're going to use the formula of A plus with n minus 1D. Then we should have A supposed to be 60 plus with 49 times with 30. Therefore, we should have the value which is 1,530 ringgit. Okay, so this is supposed to be value. So we should say that the final installment, okay, the final installment is RM 1,530 ringgit. Example 2. Each year, the price of an article depreciates by 10% of the value at the beginning of the year. If the original price of the article was RM 400, find its price after 10 years. So this is actually, we would like to find the depreciates of the price of an article. Okay, so firstly what we're going to do is we know that the original price of the article, okay, so the original price is actually 400. Okay, so now we know that this price should be decreased accordingly. So since this is actually, the decreasing is about 10%, so which means that the formula that we should have in order to have a decreasing value from this 10% is actually 1 minus with 0.1, which is, this would be equivalent to 0.9. So according to this, we should know that our first terms, okay, which means coming from the price after 1 year, so I'm going to denote by T1 here, which is the first terms. We're going to calculate this T1 according to the price after 1 year, okay, after the first depreciation, okay, which is, this should be equivalent to 400 times with 0.9. okay, so this is actually the first year that the value of depreciate, 400 times with 0.9. And then the second year is, okay, so the second year should be coming from the first terms, which is the first year as the previous year, multiply with the next, multiply with the same multiply with the same 10%, which is 0.9. okay, kita akan darabkan dengan 0.9 juga dekat sini, so which means this should be equivalent to 400 multiply with 0.9 times with 0.9, then this should be equivalent to 400 0.9 squared. Okay, and the third terms, according to this, we should know that this is also should be coming from the second terms multiplied by the 0.9, therefore we should have the 400 multiplied by 0.9 cube accordingly. So according to this, we should have the general terms or the nth terms, okay, of this situation, whereby we should have the Tn should be equivalent to 400 multiplied by 0.9 to the power of n. So this is actually the general terms that we should have in order to find the price that will be differentiate from the 400 at the 10th years, okay, at the 10th years. So now, since we already have our general terms, which is Tn, now we can predict the price after 10 years by having the T10, which means this should be equivalent to T10, which is equivalent to 400 multiplied by 0.9 to the power of 10. So this should be equivalent to, okay, if you use the calculator, okay, so 400, okay, 400 multiplied by 0.9 to the power of 10. Sorry. Then we should have 1,3 9.47. So therefore, so the price after 10 years is RM 129 ringgit 47 cent. So RM 139.47 cent. So now let's jump to example 3. So the example 3 is about the applications of according to the loan. So let's read the question first. The company borrows 5,000 from a bank. The loan is repaid by 20 equal yearly installments. The first payment being made the year after the loan was taken. If the interest charged on the loan is 5% each year, find the amount to be paid each year. So according to this, we need to find the amount that have to be paid once we have borrowed 5,000 from a bank. 5,000 from a bank, which 5% each year. Then we have to pay 20 times. 20 times equally yearly installment in order to finish the loan. So now what we're going to do is, according to this, the first things I'm going to do is we're going to let X be equals to the amount to be paid each year. So let X be the amount to be paid each year. So the next thing is we would like to find the first terms according to the, so means that here the first terms that we're looking for is actually a year after a 5,000 had been borrowed. Which means we should have for our first terms consists of 5,000 plus with 0.05, which is 5% for the interest, times with 5,000 minus with X, which is X is actually the amount to be paid each year. So according to this, we can do the factorize accordingly as having the 5,000, then we should have 1 plus 0.05 minus with X, and then we should have 5,000 times with 1.05 minus with X. So this is actually our first terms according to this one. Alright, now we would like to find the second terms, which is the second year of the installment. Second year of the installment. So it should be start from the first terms. So now we just need to have T1 plus with 0.05 times with T1 minus with X. So we know that this T1 is actually coming from the expression of 5,000 times with 1.05 minus X. But first we need to factorize them as having T1 times with 1.05 minus with X. Then we substitute T1 with the expression of 5,000 times with 1.05 minus with X. Then we need to multiply with the interest of 1.05 minus with X. Then afterwards we can expand this part, each terms, as having the 5,000 times with 1.05 squared minus with X times with 1.05 minus with X. So this is actually our second terms. And for the third terms, we should have the same as having T2 plus 0.05 T2 minus with X. Then factorize T2, we should supposed to have T2 times 1.05 minus X. Then we're supposed to substitute the expression of T2 with the expression of the second terms, which is we have 5,000 times with 1.05 squared minus X times 1.05 minus X. So after you we need to substitute this as having the 5,000 times 1.05 squared minus X 1.05 minus X. So we should multiply with 1.05 minus x, and then again we need to expand them accordingly. So now we just have 3 terms accordingly. We have 3 terms here, so we need to expand each terms. So therefore we should have the third terms as 5000 1 multiply with 1.05 cube minus with x 1.05 squared minus with x 1.05, and lastly we should have the minus x. So now you can see the pattern of our first 3 terms here according to this. Okay, so we just have a first 3 terms. Okay, so this is actually our first terms, and this is actually our second terms, and this is the third terms. So according to this, we can have our general terms of Tn by looking at this. Okay, by looking at the first 3 terms. So for the Tn, we're supposed to have 5000 times with 1.05 to the power of n minus with x 1.05 to the power of n minus 1 minus with, then we should have a triple dot, means that we still have more series actually, but we're not gonna write them all. Then I'm gonna write the 2 last terms, which is having x times with 1.05, and then lastly we should have minus x. Okay, so according to this, right, so we can factorize this out actually by factorizing the value of x. Okay, we can factorize the value of x as having the 5000 times with 1.05 to the power of n minus with x, and here, okay, I should have a series of 1.05 to the power of n minus 1 plus 1.05 to the power of n minus 2 plus until I should have x until I should have the 1.05 to the power of 1, and lastly I should have plus 1. Okay, so if I rearrange this, okay, this is actually some kind of series. So I'm gonna rearrange this as having a first term as 1. Okay, so I'm gonna rearrange as having 5000 1.05 to the power of n minus x. So now we just need to have 1 plus with 1.05 plus 1.05 squared, and lastly I should have 1 plus 0.5 to the power of n minus 1. So as you may concern that, okay, so this is actually, we call it as the geometric series. As we notice that this is supposed to be geometric series. So since it is a geometric series, therefore we can use the formula of geometric series in order to simplify that into a base of n. Okay, instead of series, then we should use the formula of E times with r to the power of n minus 1 over r minus 1. Since our r is actually equals to 1.05, which is greater than 1, that's why we just need to use the formula of E times with r to the power of n minus 1 over r minus 1. Okay, so now by using this geometric series, so we're supposed to have 5000 times with 1.05 to the power of n minus with x. So here I should have, so our A here should be equivalent to 1, which is the first term of the series. Okay, so I should have 1 times with 1.05 to the power of n minus 1 divided by 1.05 minus 1. And as we may consider as well, this 1.05 minus 1, we're supposed to have 0.05, which means this should be equivalent to 1 over 20. Okay, then when we simplify this, we're supposed to have a general terms as having 5000 times with 1.05 to the power of n minus with 20x after we simplify. Okay, then multiply with 1.05 to the power of n minus 1. Okay, so this is actually some kind of the expression for our general terms, okay, Tn. Okay, after having this Tn, then we can predict. Okay, now we can find the value of x. Okay, now you can using the general terms. Okay, so now let me just rewrite again the general terms. Okay, so now we just have the general terms of 5,000, okay, times with 1.05 to the power of n, okay, to the power of n, which is minus with 20x times with 1.05 to the power of n minus 1. Okay, so now we know that since we are looking for the value of x, which means that the amount that should be paid yearly, we know that at T20 the amount of the loan should be finished. So therefore this T20, this one should be equivalent to 0. So therefore, okay, we can say that we should equal them. 0 equals to 5,000 times with 1.05 to the power of 20, okay, because at the 20th term the loan should be finished, okay, and then minus with 20 times with x, and then here we should have 1.05 to the power of 20 minus 1. And now we need to simplify x in terms of, okay, so now we just need to have x will be equals to 5,000, okay, 5,000 1.05 to the power of 20 divided by 20 times with 1.05 to the power of 20 minus 1. Okay, alright, so this is 1.05. okay, and lastly, after you using the calculator, you should have the value which is 401. okay, therefore the amount, okay, to be paid each year is RM 401. okay,